In the equation below, variables s, t, and u represent three matrices. Which property of matrix addition is illustrated below? So before I even really look at this, let me give you an example of each of these properties. This is about to be some good notes. So take out a sheet of paper and write this down. Alright, associative property, this is the one where the only thing that moves is parentheses. So say if I had matrix A plus matrix B plus matrix C, and then I said that's equal to matrix A plus matrix B plus matrix C. Haven't really done anything yet, but here come the parentheses. Let's say on this side of the equation I put parentheses around A and B, meaning add these first and then add C. But then on the right hand side I put the parentheses around B and C, meaning add these first and then add A. That's the associative property. So for associative property, everything stays the same except for the parentheses move around. Okay, now let's talk about the identity property. When I see the word identity, I think about something that is itself, something that represents itself. Identity means something stays the same. So with addition, the only way you get to stay the same, I feel like I should change colors, is by adding 0. Okay, so say if I took matrix A and I added 0 to it, guess what that would be? Still matrix A. It gets to keep its own identity. It doesn't change. So this is the identity property, adding 0. Okay, inverse property. When you think about inverse property, you should think about things sort of canceling out. So, for example, if I have matrix A plus the opposite of matrix A, that equals 0. That would be the inverse property of addition. Okay, and then finally the commutative property. When I was a kid, I used to look at the word commute and think about how when you're commuting, you're traveling back and forth between two places. Well, that's what happens in the commutative property. Things travel around. So, for example, if I have on the left side A plus B, then on the right side I have B plus A. Okay, that would be the commutative property because things traveled around. Now, be careful. For the associative property, it looks like that's the only one that has parentheses. So sometimes students think, oh, if I see parentheses, it's automatically the associative property. Not true. Let me show you an example of the commutative property that has parentheses in it. I'm going to change the letters a little bit. Say if instead of A, I had P plus Q in parentheses. Okay, so I have P plus Q. Okay, plus, let's say, M. Alright, now this is going to be another example of the commutative property. So the commutative property is when you take two things and you swap them around. Well, if I treat the parentheses as its own thing, I can still take these two things and swap them around, and that would be the commutative property. So if I have parentheses plus M, and then on the other side I have M plus parentheses, alright, it's still the commutative property because I switched the order around. So notice, just because it has parentheses doesn't mean it's associative property. If it's associative property, the letters will be in the same order, A, B, C, A, B, C. If it's commutative property, you'll see the letters rearranged, P, Q, M, M, P, Q. So when I look at this problem right here, I see parentheses, so I'm wondering, okay, maybe it's associative property, maybe it's commutative property. The key is, are the letters in the same order? If so, it's associative property. Are the letters rearranged? In that case, it's probably the commutative property. So let's see. STU, STU. The order is the same. The only thing that moved was the parentheses. That tells me that this is the associative property. So the answer is going to be the first one.